Study about effective metal shields of high voltage distribution cable lines. By Ljubivoje M. Popovic. This chapter introduces a certain improvement, from the standpoint of applicability, the methodology that enables the analysis of complex electric circuits with an arbitrarily large number of inductively coupled elements whose relevant data are uncertain or completely unknown. In practice, such circuits are spontaneously formed by HV and EHV cable lines that pass through urban and/or suburban areas. The pulsating magnetic field created by currents in the phase conductors of these lines induces voltages and currents in their metal shields and all surrounding metal installations typical for these areas. Each of the induced currents creates its own magnetic field, which acts in such a way that reduces all other induced currents, including currents in the phase conductors of the inducing cable line. The problem arises because of the fact that these installations are, as a rule, situated under the surface of the ground, and because of that, their constructive characteristics and spatial positions are the most frequently uncertain or completely unknown. In many cases, even the total number of these installations is unknown. Because of that, the problem of determining the effects of the interaction between the mentioned cable lines and surrounding metal installations was for a long time considered practically unsolvable. Only recently was developed the methodology that is based on the test measurements of currents appearing into phase conductors of the considered cable line during a simulated ground fault in the supplied substation. Their values are utilized to compensate for the deficiency of all relevant but unknown data concerning the surrounding metal installations. It was done by introducing an equivalent cable shield substituting, from the standpoint of inductive influence, all surrounding metal installations. Here is shown that this equivalent shield is determined in such a way that it becomes identical to the actual cable line shield but only with a changed value of its longitudinal resistance. When this parameter is determined for single-core cables belonging to a certain cable line, it becomes possible to determine the actual reduction factor, inductive influence during a ground fault as well as during normal operation, and sequence impedance of the considered cable line by using a standard and well-known calculation procedures. Thank you for watching this video. Please subscribe our channel for watch more scientific research videos.